Hi friends, in this video I am going to discuss about commonly used lithium ion battery, that is 18650 battery, and I will also discuss about its inbuilt safety features. Today if you say everywhere these lithium ion batteries are used, if you take various gadgets and appliances, and battery operated vehicles are also using lithium ion batteries for their operation. The advantage of lithium, if you see here, it is the lightest of all the metals and it is having greatest electrochemical potential, which means it's a measure of how easily it can donate the electrons or lose electrons. And it also provides the largest energy density, means how much energy it can store per unit weight and or per unit volume. So this feature will have an effect on the weight and size of the power supply. If you see here, this is the periodic table after hydrogen and helium. So lithium is the thirdest material, and first two are gases, and lithium is the lightest metal that is present. And this is the atomic structure of the lithium. So it is having atomic number of 3, so which is having 3 electrons. So 2 electrons are present in the inner orbital and 1 electron is present in the external orbital. So this external electron it can easily donate. So because of this nature, lithium is highly reactive. And here you can see, so there are different materials that are present, and lithium, if you see, so it is having an oxidation potential of 3.04. so lithium is the strongest reducing agent, which means it can easily donate or lose electrons. And the measure of this property, that is lose or donate electrons, is measured by oxidation potential. Higher the value of this oxidation potential, the stronger the reducing agent is. And here you can see, the lower the value of oxidation potential, the weaker the reducing agent is. So fluorine cannot easily donate or lose its electrons. And this is the internal structure of this lithium ion battery, which is having a positive and negative electrode. Positive electrode is made up of lithium metal oxide, and the negative electrode is made up of this carbon. And during charging, so lithium ions will move from cathode to anode, and these lithium ions will be stored inside these layers of this carbon. And during discharge process, the lithium ions again will come back to its original state, and it will be occupying its state in the compound. So the lithium metal oxide, which is the cathode material, will be of different materials. It can be lithium nickel manganese cobalt oxide, which will give a cell voltage of 3.6, and lithium iron phosphate oxide, which will give 3.2 volts, lithium titanate 2.2 volts, lithium cobalt oxide 3.6 volts. And each material is having a specific advantage and disadvantage depending upon the application requirement. The type of the material will be used for the cathode. And here I'm considering lithium cobalt oxide as the cathode material. Here we can see, so this is the positive electrode, so which is a lithium cobalt oxide, so which is having a lithium atoms. And this is the carbon material, which is the negative electrode. And during the charging process, here we can see, so external voltage source is connected to the positive and negative electrode. And during this process, so because these lithium atoms can easily donate electrons, so when you apply the power supply, that is for charging, so the electrons are attracted towards this positive terminal, and lithium ions that are formed are repelled towards the negative electrode, because these are the positive ions and this is the positive electrode, so these are repelled towards the negative electrode. And these lithium ions are stored inside these layers of this carbon. And the electrons also will move from positive to negative terminals, and they are occupy the negative electrode. Here you can see lithium ions will move from this positive to negative electrode during charging process. And during discharge process, means whenever any load is connected, it can be a laptop or it can be any mobile phone. So whenever any load is connected during this powering that load, so this battery will discharge through that load. So how it is done? So here these lithium ions which are present in this negative electrode are in their unstable state. So during this process, it will again go and occupy this lithium cobalt oxide compound. So it will move through the separator. There is a separator, and these lithium ions will move towards this compound and occupy its state. And the electrons that are present inside this graphite carbon will also occupy this lithium cobalt oxide compound, but it will move towards the load. So this movement of the electrons through the load will create the current in the load, and these electrons and lithium ions again combine in this lithium cobalt oxide compound and form a stable state. So advantage of lithium ion battery, here you can see it's high energy density. So in terms of both weight and volume, these lithium ion batteries are having capacity to store more energy. So compared to its counterparts like nickel metal hydride and nickel cadmium batteries, so these are having high energy density. So these advantages, the size of and weight of the power supply comes down. And this cell voltage of this lithium ion battery is high. Here you can see lithium cobalt oxide, we are getting 3.6 volts, whereas if you see nickel metal hydride or nickel cadmium, which will generate 1.2 volts. So for high voltage applications, these nickel lithium ion batteries can be used. And the self discharge, so whenever the battery is not in use, so the discharge rate is very less. It is 1/10 compared to the of nickel metal hydride or nickel cadmium batteries. These are the advantage of lithium ion batteries. And these are the three main types of lithium ion cell that are commonly used, means their form factor. So one is a small cylindrical shape, which is commonly used, another is large prismatic type, and other is pouch type. So depending upon the application, the type of the form factor, that is cell shapes, are selected. And the highest volume of production of all these different types is a cylindrical cell, that is 18650 cylindrical cell. So this 18650 indicates the cell is having 18 mm dia. So the dia is 18 mm and the length is 65 mm. And this is the cylindrical lithium ion battery structure. So this negative and positive electrode and separator is rolled in the form of a cylinder, and at the positive terminal there are protections for overcharging, and for any short circuit there are different protections so that are present on the positive terminal side, which I will discuss. And one of the important application where these 18650 cells are used is this Tesla car. So one of the model and also so many models, they are using this Panasonic make 18650 cells. So in one model, that is S model, so they are using 7104 18650, means 7104 cells are used. So they are using in the combination of series and parallel configuration to achieving energy of 85 kilowatt hour of energy. So here we can see so how this number of cells are connected in series and parallel configuration. Here if you see, each battery or each cell is having 3.6 volts and 3400 milliampere hour. So if you want high voltage in your application, then all these are connected in series, and finally we are getting 3.6 into 4, which is 14.4 volts. And in this case current will be same. So if you see energy, so which is voltage into current into hour, that is time, so we'll get 48.96 watt hour. And if your application is not demanding high voltage, then these are all connected in parallel like this. In this case the voltage will be same, but the ampere will be multiplied, so 3.4 ah into 4. So here if you see, the energy will in both the cases will be same, but what is changing, when one configuration, that is series configuration, high voltage is generated, and in one configuration high current is generated. If your application requires both high voltage and high current, so series and parallel configuration is used. So in order to mitigate the risk, so this 18650, in addition to its advantage, it is also having disadvantages. So in order to overcome its disadvantages, so safety features are inbuilt in this 18650 cell. So like cell vent and current interrupt device and positive temperature coefficient devices are internally integrated in these cells. The cell vent, if you see, the cell vent is designed to open up in the event of buildup of pressure inside the cell. In the case of any thermal runaway, what is thermal runaway? So whenever the cell temperature is increased, so over the designed temperature, so there will be heat that is generated, and this heat in turn causes the gases, and these gases are built up inside this battery, and this heat is not properly removed, so this will further increase the temperature. So this is a continuous process, and this is known as thermal runaway. So in order to limit the thermal runaway process, so a cell vent is built inside the battery to release the pressure in case of any excess pressure. Here you can see this is the battery positive terminal. Here there is the scored dent disc. This is the disc. So this is the scored vent disc. So whenever any excess pressure is developed inside the battery because of any short circuit or overcharging conditions, so this scored vent disc will rupture and the gases will be released to the atmosphere. And in addition to that, a current interrupt device is also there. So this is the current interrupt device, CID, that is present on the battery positive terminal side. So above this CID there is a green color. Here you can see this is the disc, which is the PTC, so which I will discuss in the next slide. So what is the CID? The CID is similar to that vent cell. So the CID will prevent the this excess pressure inside the cell in case of any short circuit or overcharging. This is a non-resettable fuse. So when once it been ruptured, so this battery is no longer can be used. It should be thrown out. So this is of a non-resettable fuse. And here you can see this is the disc, so which is the PTC, positive temperature coefficient, so which will limits the current in case of any short circuit or any overcharging condition. So whenever this rated current is exceeded, so the PTC means this is a positive temperature coefficient of resistance. So this resistance will increase whenever more current is passing through that. Here you can see this is the characteristic. So whenever more current is passing, so the temperature will be increased. Whenever the temperature is increased, the resistance of this PTC is increased. So this increase of resistance will limit the current that is flowing through, that is going out of this battery, and will this protects the battery, so in case of any short circuit or overcharging condition. Here you can see this PTC resistance increases sharply with the temperature. So whenever any short is applied to the cell, the elevated currents cause the PTC to self-heat and move to a high resistance state, in which most of the cell voltage is dropped across the PTC, but the current is significantly reduced. So these are the different productions that are inbuilt in 18650 lithium ion battery. Thank you for watching my video.